Good afternoon, ladies and gentlemen. I'd like to honors. Welcome to room 15. What happens in room 15?
Learning never ends.
Thank you. Good job. Good, enthusiastic response. What we're doing today is we're going to be talking about domain, range, and end behavior. And in my teaching profession, I'm not one of these teachers that is a lecturer for most of the classes that you're going to have here, but this is one of the exceptions to that. And so I apologize for that in advance. What's wrong with lecturing for long periods of time?
We get bored. We don't pay attention.
That's right. What happens is, as human beings, we are kind of programmed to tune things out easily, and so that's why we try not to. I try not to lecture for long periods of time. That's why a lot of times if you ask me questions, I'll let you guys work things out. But this is one of these times that we're going to have to work at definitions, and so I'm going to have to ask you to try to pay extra special close attention. Don't be afraid to ask questions, and I may try to liven things up to try to ask you directly, try to keep you involved. But we have these graphics here, which are, I think, really good graphics. And so I think I have, these are amongst the best graphics I have for this class. So we'll just see as we go. But do any of these things make sense to you when we talk about, in fact, in our, yes?
Do we need a table of contents or just?
Or probably not a table of contents. No, probably not. It'll probably be just as it goes. I don't think that'd be necessary. All right. So now, domain and range we've talked about with these Algebra 2 builders quite a bit, haven't we, these last few days? But now we're going to be talking about end behavior. Does that ring a bell to anybody what end behavior is? Okay, we're going to find out what it is. How can you, here's the essential question, and it's kind of a rhetorical question at this point. How can you determine the domain, range, and end behavior of a function? So we're going to answer those questions. And we're going to examine these pieces of vocabulary today. The first one of which probably is what an interval is. So let's look at that. Okay, now an interval is part of number line without any breaks. Okay, unbroken. It's part of a number line without any breaks. And a finite interval has two endpoints which may or may not be included in the interval. And we're going to talk about what those endpoints look like. So we're going to be looking at number line graphs to begin with here. And here is that first number line graph right here. So does this graph here have endpoints?
No.
No.
Yeah. Oh yeah, it does.
Yeah, it does have endpoints. It has one here. Now, this one here at -5 is hollow, right? It's hollowed out. It's a hole, and at the right we have that filled in. And so a finite interval has two endpoints. And so is this a finite interval we're looking at here?
Yes.
Yes, it is. It says two endpoints which may or may not be included in the interval. And do you see any breaks between -5 and 3?
No.
No breaks, right? And you see two endpoints, and then it says which may or may not be included. So is this one on the left included?
No.
No, it's not. Is the one on the right included?
Yes.
So here's a good example of a finite interval, one of which has an included endpoint, the other of which has a uninvited or not included endpoint. Okay? And one way we would say this, we could say that it's greater than -5 to 3. Greater than -5, or you could say greater than -5, less than 3. So there are different notations. What we're going to do is, in fact, let me go ahead and put what some of those are. we could also say greater than -5. So we could say x is greater than -5, yet less than or equal to 3. Are you familiar with this kind of notation, inequality notation? Does that look familiar to you? Usually I'm seeing that from your algebra that you've had at the middle school, most people are pretty comfortable with this. Did you use a lot of number line notation too? Pretty familiar with that? So these are probably your two best known notations that you're already familiar with. So we're going to introduce a couple new types of notation to you today, and I hope that you're going to be able to figure out what's the equivalent number line and inequality notation to that. And again, don't be afraid to ask questions. We're talking about something that is new to you, or will be shortly. What about the word interval? Did you use the word interval at all? Does that make sense to you? Okay, so it's an interval, and logically, an interval, I think of it in terms of time. Has anybody ever done in track and field interval training? Where you go things, those are intervals, they call them. So, and here's an infinite interval. It's unbounded at one or both ends. And so here we see an example of an infinite interval. And bounded, in this case, on one end. And so this infinite interval is x is greater than -4. So you can write it like x is greater than -4. So you'll see it like that, or sometimes you could see it like this: x is greater than -4, but less than what goes up here. What goes up the right here. Did you ever use that infinity symbol in middle school? Are you familiar with that? Austin is shaking his head. Anybody else? You don't remember that? Oh, okay. Yeah, so Caitlin remembers. Okay. Do you have questions about that? This point, okay. Let's go ahead. All right. Interval. Suppose the interval consists of all real numbers greater than or equal to 1. You can use the inequality x is greater than or equal to 1 to represent the interval. And I like to say this a lot of times: x is equal to and greater than 1. That's the way I like to say it. That's the way I like to say it, and there's a reason for it that I like to say it this way, because typically the more conventional way is to say greater than or equal to. But I like to say equal to and greater than. That's pretty weird how I change the way, and you're going to see why I do that. It helps remind me. It helps me in graphing is what it helps me to do. Okay? And you can represent this on a number. Let's see what the next slide is. Okay, it doesn't have this. Next slide, or you can draw this at 1, and then you can say, okay, draw your point. So there it is, right? So basically, you're trying at this point to reinforce your familiarity with inequality notation, number line notation, and we're going to introduce set notation and interval notation today. And interval notation is going to be your go-to notation for most of your mathematical careers that remain. Okay, and here are those types of notations. I just said it so much. Verbal, number line, inequality, set, and interval notations. We're going to use all of those. I forgot to say verbal. So all these notations, and the ones that you're most familiar with are these first three, set and interval notation, not so much. Okay, now we get to notation. A notation is a type of language or convention of describing things. These notations are used to describe intervals. Does anybody here play football? Play football, okay. Two gentlemen play football here, okay. Now, I don't know if you play on often, I guess it doesn't matter. Usually the coaching staff is going to have a play that's called, right? And what they do is there a card at the sideline that they point out?
They do signals.
They do signals, okay. But that signal, the signals they give, that's a type of language, isn't it? It's a language that hopefully you know, the other team doesn't know, right? But it's a language, and so it's a type of notation, if you will. So these things that we're doing are different types of notation, but in our case here, we're trying to get everybody to understand. We're not trying to keep it away from everybody in the classroom. We're trying to make sure, and why do we have all these different types of notations for mathematics? What do you think?
Oh, me?
Yeah, well, why do you think we have these different types of notations for intervals?
I don't know.
Yeah,
There's
what
a lot of
happened is,
differences, a lot of different-
yeah, the mathematics has evolved in different places of the world at different times, and sometimes notations, particular notations, are easier for certain things. And since they're all part of the big mathematical knowledge convention universe, let's get as familiar with these as we can, so that we can understand other mathematicians. And what I'm going to do is I'm going to have you fill out a table shortly. It's going to be a table that has this in it. So I want you to fill out a table like this, and I'm going to have you write what is in this table right here. So in your notebook, you're just going to have this. So take 5-10 minutes putting that together, and we're going to 126. So we should be able to get through this today. Do you think? And one thing we haven't talked about in detail yet is set notation and interval notation. So these two right columns might be the first time you've seen those things. And we're going to gradually explain what they are. So don't worry about it. I want to see, I forgot to ask the Algebra 2 people, is there anybody who didn't get one of the a class syllabus, because I have extra copies today? You didn't get one here, Gregory? Okay. I'll get you one, Gregory. Is it okay if I call you Greg? Yeah, because one reason I want to do that is I once worked for a guy whose name was Greg. And I actually liked him. He was a good boss, so I wanted to be my friend.
Mr. G, we never got to sing that song yesterday.
What song?
One that's on the board that we sing together.
Oh, this one here?
Yeah.
Where do I start my line?
Yeah.
You want to sing it right now?
Yeah, you said we were gonna sing it yesterday.
Oh, did I? Okay, I lied to you? Okay. Let me see, I don't know what my low register is like today. Yeah, we could do that, probably won't. Probably not even hurt us too much. And I can throw that other verse about the intercept really strong. Okay, yeah. It is gonna be heavy because a long, long time ago. Now over a year's past, and my mind is full of ask with some memories that are due. But now I'm back in school this session. I've got a sad confession. My skills dropped a big step. Fractions, a lot of concepts. But Algebra 1 has been so long. That's why my teacher sings a song. Because when he saw my work, it was all along. So that's why we're to sing this song. Where do I start my find the y-intercept and things will be fine. 3, 2, 1, 1. So use the slope, it's rise over the slope, it's rise over run. That we beacon, we use the slope, it's rise over run. It's the m in front of x. The thing on top, and to move up and stop. Almost done, but there's one more hop. Now use the run and move to the right. Draw your dot. Are we done? No, not quite. Draw the line to connect the dots. But draw errors because lines never stop. Think I can rest, but I remember the process. But I always check my work because I might be wrong. Okay, and then now we can graph a line, but there's more ways we'll use next time. Like the T-charts we once saw, an intercept's really strong. It's a trick we'll use all year long, but now got to move along. So for now, we'll sing this song. We were singing, where do I start my last? Find a y-intercept and things will be fine. Need to find so you can slope its rise over run. You guys did a good job on that. I could see people singing here, and I'll tell you what, Carmen, I really liked your head motion during that. It was really good. Like, you know how she did that with the head, keeping her head level. How do you do that? I'm not coordinated enough or flexible
Can you show
enough.
everybody how you do that?
She gets the head like keeps the head level, but moves it from left to right. You know what I'm talking about?
I didn't even realize I was doing that.
It's just a natural dance. It's because she's just a skilled dancer to be able to do that, I gotta say. All right, very good. So how are you doing on the table, getting the table ready? About done with that? Let's see here.
Mr. G, you trying to be about be real? For what?
Be real time, right?
Yeah.
Be real?
Yeah.
Yeah, you wanna be on Be Real?
What is that? What's be real?
It's like this, it like shows, you take a picture at a certain time of the day and it shows your front view and like both cameras take a picture.
Can I
Okay.
take your class Be Real?
No, because we can't be doing that. We can't call that today proper cell phone use. Please listen.
I feel like that's proper.
But it's be real time. It just went off.
It's
All right. Let's go here. Okay, notation for domain and range, and we're going here, aren't we, to 26? Okay, good. Okay, set notation. Here's an example of set notation. You ever seen something like that? It's called set notation or set builder notation. Now, we did this a couple times, didn't we, in the Algebra 2 builder? A little bit, remember that? So we've already talked about it, so I'm glad we did it for that reason alone. And so, that's what this way. And what this is, this thing here, I'm trying to remember what I had here. Let me go ahead and tell you what it, verbally how you say it. This little vertical line segment, what you do, it reads like this, X, and verbally, you would say this vertical line segment, it's X such that, that's what that little vertical line segment is, such that X is greater than or equal to 1. And most of the time, where it's one-sided, like this, you'll see it. You could also see it like, I'll just give you a pause. You could have X such that it could be, you could possibly see it like, oh, I got it wrong. Yeah, 1, so be 1 is less than or equal to X, which is less than infinity. So you could possibly see it like this, but can you see that this one up here in red, it's more efficient than this notation down here, just because it has less wordiness to it. So that's something to get ready for. Okay, and now interval notation. Okay, interval notation uses brackets, commas, and parentheses. That's interval notation. And this is where you're headed. Starting this year, and especially in calculus and pre-calculus and most of the rest of your mathematical careers, however long they happen to be, you're going to use or be able to use interval notation most of the time. So you'll see this a lot. Have you ever seen this notation before? You have? Who's seen it before?
I've seen it.
Okay, Addison's seen it. You've seen it too, Caitlin? Where have you seen it, ladies? You remember where you've seen it? Don't remember where you've seen it? You seen it, was it in Mrs. Tubbs?
I saw Miss Woodham's class.
Okay, so you might have been briefly exposed to it, but now, starting now, it's going to be more of a go-to thing. Okay, that's what it's going to be. And I guess one reason you don't see it as much earlier is you don't see anything about X here, do you? So it's just, so you already have to assume what that variable is just to have this. All right. Here's another example of interval notation. And I'm going to give you a translation for this. This is going to be, what it's going to be, it's going to be on a number line, for example. It's going to look like this. Let me get a different color. Okay? So that's what that's going to look like right there. And the key thing you're doing is you're looking, you look over on the left side here, and I didn't do a number line for this one, but here are the critical points. You have -3 and then -3, and then we have 5.5, And so here, you have a parentheses. So with the parentheses, you have this, a hole. And here with a bracket, you have the open dot like this. And then you're filled in between. So this is a finite interval. And this next one over here, is this a finite or infinite interval? It's infinite, right? Because it has one or both sides unbounded. Okay? And again, interval notation. So we've talked about this a little bit. Another thing you could have is, like, I'll just do the bottom one, what that looks like in number line notation. Go like this. And so at 5, you have this. So what you're doing is you go like this, and then it's less than. So it's going to go like this. So that's what this is going to look like here. So you're going to just get used to different ways of writing the same thing. And that's it. Okay, inequality notation, interval notation. And by the way, these are not exactly the same thing. This one here is greater than or equal to 1. This one is greater than, this one is greater than or equal to 1. This one is greater than 1. So they're not the same thing.
But how do we know it's greater than this or what?
Okay, great. Greater is parentheses. Greater than or equal to is going to be brackets. So if I want to make this greater than or equal to, I would write it like this. So here's your greater than or equal to on the right. Your greater than is on the left. And the book uses the plus for plus infinity a lot. I don't. If I just see an infinity there, to me that means plus. The exception where it says negative out front is negative infinity. Another thing you got to be concerned about in interval notation is your convention is you're going to put the numbers that are lowest, least to greatest, left to right. So in other words, this one here, you wouldn't write this one like this. This would on the bottom would not be a way to write it. The way on top would be the way to write it, going left to right. Okay, let's see here. Okay, notation for domain and range. So we're going to kind of, I think we'll probably end it here today, just going in. I'm just going to give an example. Copy and complete each table. So here, as an inequality notation, we see the lowest value being -3, the highest value being 4. So in inequality notation, we can put this from -3 to 4 over here, and we know that x is going to be greater than or equal to -3, yet less than or equal to 4. So your x is going to be sandwiched in between these two numbers. And then in set notation is very similar to inequality notation. So make an opening bracket like this. Then you can have x such that okay, so very much like that. Interval notation, you would write that as and then over here on the right, so that's, you have questions on this one here at the left. Now here, on the right, you have an infinite interval. So in inequality notation, you write it like this. set notation, you write it like this, x you can write it different ways. You can just take this and write it down, or you can also write it like this and make a little sideways E. Have you ever seen something like this R like this? You haven't?
No.
This double script, bold script R, this one right here is notation for all real numbers.
Oh, yeah, I've seen that before.
And the sideways looking E, that means is an element of. Is an element of. Let me write that down. So this E, I'm going to put it like this. Is an element of. Our bell's going to ring on us soon. And then we have interval notation is going to be like this. Okay? And also you can take this inequality notation here and just plop it down in here and set notation too, like this. So you have a little bit of different options on that. We're just going to try to keep it here today. I like the class today. I've been posting the videos for the other class. I'm going to try to post today's video. We're going to try to keep it at the same level. We had some good discussion, I thought. So, yeah, kind of a lecture day today. Tomorrow will be similarly lecture, but it seems like you were awake and asking some good questions. We did the best we could. So we'll just keep it like that.
What's that thing connected up there?
They got a little connector right there, that white thing.
Oh, yeah.
Just connects it to that way.
Pretty helpful.
That's pretty good. I like it. It's pretty good.